Good morning, ladies and gentlemen. In this video, I'll show you the steps required to train and implement an autopilot on a real-life donkey car. So in this part of the video, you can see I'm manually driving the donkey car around the track using the Logitech game controller. Furthermore, you'll also see that after a few laps in a certain direction, I change the direction of the donkey car so that once the final CNN model has been trained, the donkey car will be able to drive in both directions. This video was shot on a particularly hot day here in Potchefstroom, so the donkey car was prone to overheating, so I had to take it off the track several times and blow it on the heat sinks in order to let it cool down so that it could drive again around normally. After gathering some driving data, I connected to the donkey car via the hotspot on the Jetson Nano, and I used the mobile Xterm application in order to transfer all of the manual driving data that was recorded to the host computer that will be later used for training. I connect to the Jetson Nano of the donkeycar using the SSH protocol, and I navigate to the donkeycar application inside of the Jetson Nano development board. As you can see, I go to the data directory and I will use the mobile XTerm application to transfer it to my local host computer using the download command. After transferring the data to the host computer, we must make sure that it is inside of our donkeycar application. We then open up an Anaconda terminal where we activate the virtual donkey environment and navigate to our donkeycar application. In order to train the autopilot, we type in the command Python followed by the train.py file. Then we must specify the file path to where the recorded data is, as well as the name we wish to give to our model and as the type of model as well. Note that as previously shown in the other videos for the simulation environment, the default linear architecture of the donkeycar software was changed to correspond to the CNN architecture described in the report that was developed using the optimization technique. Once the training has been completed, we can go to the models directory inside of our donkeycar application, and as we can see, the trained model is located here. On the right hand side, you can see a loss curve of the trained model. Next, we will use mobile xterm again to transfer the trained model to the donkeycar. As you can see, we can use the mobile xterm application to navigate to our donkeycar application on side of the actual donkeycar, and we can simply drag and drop our trained model inside of the models directory of our donkeycar application on the physical donkeycar. Once I've transferred the trained model to the physical donkeycar, I use PuTTY to connect to the physical donkeycar and will navigate to the directory of the donkeycar application inside of the physical donkeycar. The command shown on the screen is executed to prevent a memory error from occurring when the trained model is loaded. Next, the following command is typed to allow the trained model to autonomously control the physical donkeycar. And the command is Python followed by the manage.py file as well as the drive command, and then we must specify the name of the trained model that we wish to use. Once everything has been loaded, we can navigate to the following web address and set the mode of operation of the physical donkeycar to local pilot that will use the trained model to control it. In this part, you can see that the trained model is able to autonomously control the donkeycar and allows it to autonomously drive around the track. You will now see I will pick up the donkeycar and change its direction to show you that it is able to drive in the other direction also autonomously.